In this quick video, I'll show you 3 examples on how to transform the natural exponential function e to the power of x. Specifically, we'll focus on how to vertically and horizontally stretch and compress the exponential function. We will also apply reflections in question 3. Just to recollect, the rules to vertical and horizontal stretches and compressions are shown below. And in question number 1, we'll be focusing on this one specifically. What happens when your x variable is being multiplied to a number? Notice that in our first question, they ask, sketch the curve of y is equal to e to the power of 5x, beginning with the graph y is equal to ex. This right here represents y is equal to ex, and notice how it passes through the y-axis at 1, 0 and 1 specifically. So to do this effectively, you'll notice that this x is being multiplied to the 5, and according to this right here, it says that if you have a situation like this, you compress the graph horizontally by a factor of c. This right here represents our c. So horizontally means from left to right. So all of these points along the x will be divided by 5. So this point right here, let's pretend that it was 5. It would be divided by 5 and it becomes 1. So this point ends up becoming here. For example, if this is 4, you divide 4 by 5, and you end up with 0.8. This one over here, let's pretend it was 3. 3 divided by 5 is 0.6. And eventually, you would end up to a point where it will pass that same y-intercept. It will still have the same y-intercept, but it will be compressed. Now to do this effectively, I'll zoom in, try to connect these points the best I can, and it'll still pass through this point right here. And everything else, of course, will be compressed on this side as well. And it would end up looking like this. Let's move on to the next question. In question number 2 this time, they want us to sketch the curve of y is equal to e to the power of x over 5, beginning with the graph y is equal to ex. And this time our x's, let's take a look here, we'll stretch the graph of y is equal to f at x horizontally by a factor of c. So we'll be stretching every point along the curve by 5. So if this point right here is a 5, for example, okay, you'll multiply that number by 5 and it becomes 25. So you end up with something that is heavily stretched. And a point right here would be somewhere along here. And you would end up with a curve that still passes through y is equal to 1, but it's heavily stretched. So you would end up with a curve looking like this. In our last example, which happens to be the most difficult one, we are expected to sketch the curve y is equal to negative 4 e to the power of negative 3x. The first transformation that we will apply is this one right here. And what that tells us is that we will compress this curve by a factor of 3. So the first thing that we have to do is compress the curve by a factor of 3. That's the first thing. So all of these points will be compressed. This will be compressed by a factor of 3. So if that's a 5, 5 divided by 3 is 1.66. So this would be somewhere along here. And so we would have a curve looking like this. Our next transformation will be to apply this negative. And that negative, according to this part right here specifically, it says reflect the graph of y is equal to x about the y-axis. So the next step is to reflect about the y-axis. So what does that mean specifically? It means that we're going to take a mirror image of this purple curve right now going the opposite way. So what I'll draw in orange is part 2. Our next transformation will be to apply this 4. And I'm going to use pink for this. And what that tells us, if you take a look here, it says that if you have a value c in front of f at x, you stretch the graph vertically this time by a factor of c. So we have to stretch vertically by a factor of 4. To do this, you're going to take all the y coordinates along this orange curve and multiply it by 4. So this point right here has a y coordinate of 1. That's going to become 4, and it's going to be up here. And you don't have to be entirely accurate doing this. And there you have it. That curve represents our third transformation. And finally, in green, we'll have our last transformation, this negative. And what does that negative tell us? Well, according to this, that negative tells us that we have to reflect about the x-axis. And what this means is that we have to take a mirror image of this curve right here along the x-axis. So notice the distance from here to here. That distance needs to be replicated from here to here, and we end up with something that looks like this, and it will have to pass through -4 as well. And there you have it. That is how to perform transformations on the natural exponential function e to the power of x. If you found this tutorial helpful, please support our channel by subscribing or by liking this video. If you have any further questions, you may visit our website at studyforce.com. We are an online service for students seeking free homework help. See you soon.